Hello everybody! We are looking at our very first pre-algebra video made by Miss Peterson. This is called Using Intercepts, and it is section 8.3 in your textbook. We're looking at what's called the x-intercept and y-intercept and using these to graph equations. The x-coordinate of a point where a graph crosses the x-axis is called the x-intercept. And we'll take a look at what this means on the graph. And this is similar with the y-intercept. So if we take a look at a graph, let's say I have a line that crosses the y-axis at, say, 0, 4, and then it crosses the x-axis at 2, 0, for example. 0, 4, and 2, 0. I would say that my y-intercept is 4, and my x-intercept is 2. Again, where my line crosses the x-axis, referred to as the x-intercept, and where I cross the y-axis is my y-intercept. You can see in this graph that where the y-intercept is, the x-coordinate is always 0, and where the x-intercept is, the y-coordinate is always 0. So to find our intercepts, we're going to find the x-intercept of a line, we'll substitute 0 for y in the line's equation, solve for x, and similarly for y. So let's see what this looks like. Let's say we want to find the intercepts. Find the intercepts of the graph 2y equals x plus 2. Well, to find the x-intercept, let's plug in 0 for y. So to find the x-intercept, I'm going to substitute 0 for y. Now that equals x plus 2. So 2 times 0 is 0 equals x plus 2. I'm going to subtract 2 from both sides, and I get x equals negative 2. This is my x-intercept. And remember, the x-intercept happens where the graph crosses the x-axis, therefore my y-coordinate must be 0. Similarly, to find the y-intercept, I'm going to substitute 0 for x. So I've rewritten the equation. I have 2y equals, I'm substituting 0 for x. So I'll get 2y equals 2. And solve. Y equals 1. This is my y-intercept. My y-intercept because x is equal to 0. So I know that I'm going to cross the y-axis because x is equal to 0 along the y-axis. Let's try this with another equation. Let's find the intercepts and also graph the line of the equation 3x minus 2y equals 6. Let's find the x-intercept here. We'll plug in 0 for y. So I get 3x, let's see, 2 times 0 is just 0. So this will just be 3x equals 6. Divide by 3 on both sides. I get x equals 2 for my x-intercept. For the y-intercept, similarly, I'm going to plug in 0 for x minus 2y equals 6. Well, again, 3 times 0 is just 0. So this leaves me with negative 2y equals 6. I can divide by negative 2 on both sides. Get y equals negative 3. This is my y-intercept. So when I graph, it's a really quick way to graph this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. X-axis, y-axis. This will look much nicer on your graph paper. X equals 2 is here. Y equals negative 3. 1, 2, negative 3 is here. I only need 2 points to make a line. I connect. I've just graphed a line using the intercepts. Once again, here's the x-intercept of 2, 0, and here's the y-intercept of 0, negative 3. Let's now take a look at the following problem and see how we can apply this. While at the beach, you can rent a boogie board for $1 per hour or a surfboard for $2 per hour. what a deal. I think now at Hermosa Beach, it's more than that, maybe $10 an hour. You have $10 to spend. Write and graph the equation describing the possible combination of hours X renting a boogie board and hours Y renting a surfboard. So in this problem, we're told that X is hours renting a boogie board. Say hours renting the boogie. Y is hours renting surfboard. Hours renting surfboard. We've only got $10 to spend. So we could set up an equation and say that we've got, let's see, $1 per hour for X hours on the boogie board, plus $2 per hour for Y hours with the surfboard. If we've got $10 to spend, we could say that the combination of these two could be equal to 10. We can't spend any more than that. So when we graph this line, that'll give us the possible combinations of how many hours on the boogie board and how many hours on the surfboard we could get for $10. So one way we could graph this equation is using our intercepts. So to find the x-intercept, I have 1x, or just x, plus, we're going to make y 0. Oops. 1x plus, let me fix that here, 2 times 0 equals 10. So this simplifies as just x equals 10 for our x-intercept. For the y-intercept, we're going to plug in 0 for x, so I could say 0 plus 2y equals 10. Therefore, y equals 5. When we graph this line, my x-intercept, I'm going to count in 2's here. 2, 4, 6, 8. Ooh, not quite long enough. Again, this will look much nicer on your guys' graph paper. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Let's see, x-intercept of 10, and our y-intercept 2, 4, so 5 will actually be halfway in between 4 and 6. Connect the dots, and here's what our line looks like. Well, what does this mean? Well, at the point 0, 5, can you guess what that means? It would be 0 hours, this point, the y-intercept 0, 5, would mean 0 hours on the boogie board, but 5 hours with the surfboard. So this combination gives us 5 hours surfboard, no boogie board at all. And as we move across the line, we get different combinations of these hours until I get here. We've got, let's see, the point is 10, 0. So this would be 10 hours on the boogie board. Wow, it's a long time at the beach. And 0 hours on the surfboard. Everything in between is all the different combinations. But what does it mean on this part of the graph? Well, actually, since we're talking about time, we can't be negative, so really my graph doesn't even need to continue down to this point. I could stop my graph right here. So be aware of what you're graphing. If we're talking about time, I can't be negative. I hope this was a helpful way to have an introduction to x and y intercepts. Please come to class tomorrow with any questions, comments, ready to go. I'll see you guys tomorrow.